and welcome to the presentation on geolocation. You may be familiar with the terms related to geolocation, although you may not have used the word geolocation itself. When we think of traveling down a highway using a GPS, or even looking up the address of a business using Google Maps, we're in turn performing some sort of geolocation process. Now, Oxford Dictionary defines geolocation as the process or technique of identifying the geographic location of a person or device by means of digital information processed via the internet. In short, what that means is we're able to tell where a device is located, and we're able to process that information using a GIS system of some kind that's connected. Geolocation can go beyond that. I mentioned you could use Google Maps to, for example, pull the address, so a meaningful address of a business based on some coordinates you have, or vice versa. You could look up a business name and find locations for that. So we'll talk about geolocation in this high-level, broad context, and then work our way down into specific applications and then the unique terminologies that you use in those circumstances. We want to really start with thinking about positioning systems. When I mention positioning systems, most of you are probably thinking the term GPS. And we use that in our nomenclature, and we use GPS to locate things. And you've heard movies and TV shows all refer to GPS, so you're definitely going to be familiar with that term, but we're going to explore that in a little more detail. Now, when we're talking about positioning systems, there's several types. The first type are known as global navigation satellite systems, and there's several of these, and one of these, of course, is GPS. Now, there's some alternative systems. Actually, there are augmentative systems that work with GPS. One is known as a satellite-based augmentation system. The other is known as a ground-based augmentation system. Another type of positioning system is a real-time locating system. And these are generally going to be found indoors in warehouses and other areas where you have a small area and you're trying to find objects in that area, like shipping pallets or containers. And then the third type that we'll talk about as a broader type is the Global System for Mobile Communications, or GSM, which also has some positioning system capabilities.
Navstar Global Positioning System is a space-based network of satellites, transmitting precise, jam-resistant radio navigational signals. Current plans call for 18 satellites orbiting the Earth every 12 hours. They will provide highly accurate and continuous global coverage to authorized users by the late 1980s. The Global Positioning System can pinpoint an aircraft, land vehicle, or seagoing vessel within 16 meters or 52 feet of its actual location in longitude, latitude, altitude, and speed.
When we talk about global navigation satellite systems, I mentioned GPS is one of the most common that we refer to. The technical name, or the original name of that, was Navstar, but GPS is a US, I believe also Canada contributes to the system, a global navigation system. There's also GLONASS, which is a Russian system, Baidu, which is a Chinese system, and Galileo, which is a European system. And these systems generally have an accuracy to about 20 meters or 60 feet. When we think of global navigation satellite systems, there are some issues we have to consider. The first concern is something known as selective availability. In the United States, selective availability is disabled by law. However, in the past, governments and military organizations could use selective availability to reduce the accuracy or to provide false information through a global navigation satellite system. Now, this would be useful in times of conflict, or for example during a terror strike, by adjusting the ability for GPS to be very precise. You can prevent it from being used in attacks, for example. However, in today's economy, we are so relied on global navigation satellite systems, trucking companies, shipping companies, aircraft. So many systems use this that manipulating the accuracy could actually be dangerous in itself. Another type of concern we have is related to clock errors. The way GPS works, or any of these satellite navigation systems work, is they send out a signal from a satellite, and that signal contains a time code. When the signal is received by a GPS receiver, it can tell when this message was sent and how long it took to get to the device by comparing the clocks. And if there's any inaccuracy in the clock of the device or in the satellite that sent the signal, there are going to be some errors. And even the slightest errors can cause some incorrect readings of the position. There's also atmospheric conditions. So these could be based on water droplets in the atmosphere, anything that's going to degrade that signal from traveling from the satellite to the receiver. Because remember, the longer it takes, the further away your device or the receiver will think it is from the satellite. And some other things that might come up are jamming and spoofing. Now, of course, these are illegal in the United States, but jamming refers to sending out other signals to essentially create a lot of noise so that a GPS receiver cannot determine the correct signal that it's receiving. And spoofing is actually recreating the satellite signal, usually from a ground-based terrestrial station, and having the device think it's actually reading the satellite times when it is reading the incorrect times sent from the spoofing device. Now, these are both very sophisticated techniques that are probably going to be applied by military groups, that kind of a thing, that can afford to create these systems and would know how to design the system so that a GPS receiver would actually take these signals and incorrectly position itself. To overcome the issues I just mentioned, there are several other techniques, and these are the augmentation systems I mentioned earlier. So there's satellite-based augmentation systems, or SBAS, that essentially send out a secondary signal that can be used to more precisely define your location. While traditional GPS is accurate from about 20 meters, or accurate to about 20 meters, these types of systems can bring that accuracy to about 2 meters or even less. Now, the first one we see, we have these logos that will look very much like consumer organizations versus the first logos looked very much like military organizations. And that's because most of these are either consumer organizations or governmental entities that are not necessarily the military. And you'll see that the left two, we have a Japanese system as the first one, which is the multifunctional satellite augmentation system. Then we also have GAGAN, which is Indian. So the first one is Japanese. If you look really close at the logo, you can see this shape that looks like the infinity symbol. And there's a small loop at the top, which is going to be over Japan. And then there's a larger loop that goes all the way down to Australia. So that's going to provide some detailed positioning for that region. GAGAN works in India, and it will allow you to more precisely position things in India. And Starfire and Starfix, which are from John Deere and Fugro, are actually going to work globally, and they provide extreme precision. Both, I believe, are under 1 meter accuracy. When we think of John Deere, we think of agricultural equipment, and that's exactly who they developed this for. If you've ever seen agricultural equipment, oftentimes it may operate autonomously, and other times the vehicles may actually have a driver, but the system adjusts itself based on the location it positions itself to. So for example, it could lower a blade or lower a plow, that kind of a thing, based on where it knows it is in the field. And Fugro is a mining company, very similar to that. They'll be able to adjust the blades or their trucks and position their vehicles very precisely in a mine where safety is paramount, and also it's important to keep all this equipment moving around safely. So in addition to these satellite-based augmentation systems, there are several ground-based augmentation systems, and most of these will come from military contractors and avionics companies. So the few I've listed here are SmartPath. We also have NavBlue and AirPark. And those systems are from Airbus, Honeywell, and Northrop Grumman. Another one I have on the slide is the Coast Guard system, which is the DGPS. So that was a terrestrial differential GPS, and that system is actually shutting down or has already shut down. That process started a few years ago, and I believe it'll be fully decommissioned shortly if it's not yet. But the military systems, as well as the Honeywell and Airbus, obviously those are aircraft manufacturers, avionics manufacturers and suppliers. Here's a diagram I found, I believe on Wikipedia, that somebody put together, and it kind of clearly shows how these systems work together, so you can kind of get a good idea. But the truck essentially represents the GPS receiver, and you see the satellites on the left there. Those are the GPS satellites. So they're sending out a signal and positioning that truck, but then that truck is also receiving the augmented information from the ground-based system, which looks like it's broadcasting from a cell phone tower, as well as from a private, most likely satellite constellation that's also providing some corrective information, allowing that truck to position itself much more precisely. In modern systems, that can be down to accuracy, down to maybe even 4 inches. So it's extremely precise. Now, we talked about these systems using satellites and positioning things globally. We can also position things or locate things in small areas like shipyards or even indoor warehouses. And these systems are real-time locating systems or local positioning systems. And they help us identify and track objects in these warehouses, essentially. They don't have the telematics information that we would see with GPS systems. So in other words, when they receive this signal, the devices aren't really able to calculate their speed, direction, and orientation. However, that information does get relayed back to the system that's sending out, so you would actually know where this thing is positioned inside, for example, a warehouse. And there's lots of different technologies that you can use for a system like this. For example, you could use something called active RFID, which is essentially an RFID system, but it's powered, so it's going to be able to send out a signal. There's also optical location. We're using cameras to detect objects in a warehouse. There are radio beacons, some really short-range Bluetooth systems. There's also systems that work with a wireless network in the building, or active infrared to tell where these different objects are. And a third system is GSM, and that's a global system for mobile communications. Essentially, if you've ever watched a movie where they're trying to find someone and they're using the cell phone signal, right? You have various antennas, and a device or a cell phone is connected to these different antennas. And based on the signal strength, you would be able to tell where this device is. So for example, if you looked at your phone and you could tell exactly how many towers it's connected to, if you knew the location of the towers and where the strongest signal was coming from, you could essentially triangulate or plot your location using a system like that. There's actually 3 layers this works on. It works at the network level, so centrally you could coordinate and find a device. It also works at the device level, so when the device is powered on, it's pinging these different systems, and it works at the SIM card level. So if the device is not connected to the network, you should still be able to connect to that particular SIM card, which is kind of interesting. And in addition to GSM, ECID, and LTE offer some greater precision than we had before. And of course, all of this is now connected with GPS and local area networks, so you can even get to greater precision using these systems. Thank you for watching. I hope that the information I provided to you will help you with your information systems and your location analytics career.